Now I'm going to try to find the position and velocity vectors for my basketball shot for any time t. So I'm going to start with what I already know, which is the acceleration due to gravity. Since gravity is a downward vertical force of 9.8 meters per second squared with no horizontal force, the acceleration of the ball is going to be represented by the vector 0, 9.8 meters per second squared. Since our units for the basketball court are in feet, we have to convert the units from meters to feet, so the acceleration vector becomes 0, 32 feet per second squared. Now that we know the acceleration vector, we can use it to find the velocity and position vectors. The velocity vector is the integral of the acceleration vector, which is c sub 1, negative 32t plus c sub 2 feet per second. The position vector is the integral of the velocity vector, which is c sub 1t plus c sub 3, negative 16t squared plus c sub 2t plus c sub 4 feet. Now we just solve for our c values. The easiest ones to find are c sub 3 and c sub 4, because those are the values of the basketball's initial position, and we can isolate those values by plugging in t equals 0 seconds. In order to find that, we have to look at the initial position of the basketball. So looking at this picture, x of 0 is 0 feet and y of 0 is about 5 feet. This means c sub 3 equals 0 feet and c sub 4 equals 5 feet. After plugging c sub 3 and c sub 4 into the vector, we can use the final position to find c sub 1 and c sub 2. When we plug in the time when the basketball reaches the hoop, t equals 2 seconds, we see that x of 2 is 15 feet and y of 2 is 10 feet. When we solve, we get c sub 1 equals 15 halves and c sub 2 is 69 halves. Now we can plug in our c values to get our final answers. The velocity vector is 15 over 2, negative 32t plus 69 over 2 feet per second. Our position vector is 15 over 2t, negative 16t squared plus 69 over 2t plus 5 feet. To find the tangent line at t equals 1 second, I plug t equals 1 into the position vector to find the x of 1 and y of 1 values. I then plug t equals 1 into the velocity vector and divided y prime of 1 by x prime of 1 to find the slope of the tangent line. My answer for the tangent line was y minus 47 halves equals 1/3 times x minus 15 halves. Next, to find the speed at t equals 1 second, I used the equation and plugged t equals 1 into the velocity vector before plugging the x prime of 1 and the y prime of 1 values in and getting the speed of 7.906 feet per second. To find the direction, I plugged t equals 1 second into the position vector to find the y of 1 and x of 1 values. When I plugged these values into the equation with my calculator, I got theta equals 1.262. Finally, to find the distance from when the ball left my hand to when it reached the basketball hoop, I used the x prime of t and the y prime of t from the velocity vector. The a value starting time was t equals 0 seconds, and the b value final time was t equals 2 seconds. Using my calculator, I got a distance of 36.85 feet.